Hi, and welcome to Year 1 A-Level Stats, Chapter 3. This is one of 3 super quick, super proof chapters. These are really straightforward because it's primarily just recap from GCSE work. So this is a representation of data. Let's get started. We've got 5 things to look at. First things first is outliers. Outliers based on extreme value that can affect the data as a whole. Sometimes you might ignore it for calculating the average, whether that's mean, mode, or median. Sometimes you might include it. You're often asked to describe when you would and when you wouldn't include it. Main thing you see it for is in box plots, where they won't include it. In the main box plot, they'll leave it to one side as an X, and that's how you know someone is an outlier. The other place you see it is you are asked to define an outlier. There's basically 2 ways you see this. You can either be X standard deviations above or below the mean, where X will be given in the question, or you could be X interquartile ranges above and below the upper and lower quartiles. And again, you'll be told how many interquartile ranges to take. So, quick example question. Here we've got a company. We've done some summaries for how much they got from sales. And we are asked to work out what the outliers are. So any outlier is either 1.5 interquartile ranges above or below the respective upper and lower quartiles. So the interquartile range here is going to be the upper quartile minus the lower quartile, which is 7. We can then do 1.5 times the interquartile range, which should give us 10.5. And that's the value we're looking for. So let's see if any of these are outliers. So I do the lower quartile minus this 10.5 value, so that's going to be my key value here. That gives me minus 3.5, so there are going to be no, I'll call them lower outliers. And we do the exact same thing with the upper quartile. We would do 14 plus 10.5, that would give me 24.5, so we have one outlier. We have 25 as an upper outlier. So when we draw our box plot, we do not want to include that 25. I'll do a box plot anyway, it doesn't look fairly horrendous. Box plots, you want 5 things. You want a minimum, a lower quartile, a median, an upper quartile, and a maximum. In this case, my minimum is 3, lower quartile is 7, median is 12, upper quartile is 14. Our highest value is going to be 20, and that's because 25 is an outlier. And then you basically connect it into the standard box plot formation. Okay, I know of course you'd have an actual graph to this on, so it'll look a lot less rubbish from that, but that's the gist of what you want. Box plots you've basically seen. A box plot is a box plot, it has 5 points, I've already said that. Cumulative frequency, for equally more interesting. Main thing to know is basically how to read quartiles off this thing. So what you're often quite asked to do is draw a box plot from a cumulative frequency graph. So let's do that now. So I need the minimum, that is going to be 50. If you want the lower quartile, that's going to be 1/4 of the data. We can see here we've got 400 points, so my lower quartile is going to be the 100th value. So we read across, hit the line, and then we go down. And that will be my lower quartile for my box plot as well. The median is going to be halfway, so again 400 points, my median is going to be 200, so go across, then go down, that is my median. Same for the upper quartile, we'll be at 300, because that is 3/4. We go down, and we've also got a maximum. There's sometimes in estimation work, I'm going to say it looks to me to be about there for the maximum. So let's drag that line down, and that's my max. And that's basically all you need to know about cumulative frequency graphs. Again, it should mostly be GCSE stuff, so it shouldn't be a challenge. Histograms, again GCSE stuff, is like bar charts of variable width. One thing that might throw you is when we do a bunch of times, we round to the nearest minute. So here, delay in minutes was 4 to 6. That's not entirely true, because the rounded is actually 3.5 to 6.5. That means this has a width of 3, and if we look here, we then do this width of 3 times 2 to give us a total number 6. So remember, your number of motorists, or this frequency, whatever it's going to be, corresponds to the area of each little bar. So to work out 7 to 8, we're going to work out the area of this thing. So this has a width of 2. Let's actually get an extra column for that. So again, because we've rounded to the nearest whole number, our widths are always slightly bigger. So this isn't 7 to 8, this is actually 6.5 to 8.5. So the width is going to be 2, here it was 3. 9 will have a width of 1, 10 to 12 will be a width of 3, 13 to 15 will be a width of 3, and 16 to 20 will be a width of 5. Okay, again, all comes from bounds. So if I look here, the height for 7 to 8 was 7. 7 times 2 gives us 14 motorists. The rest you can check. 21 times 1 is 21. This times 3 is 45, and so on and so forth. And lastly, we have a width of 1. So we do 5 times 1, which gives us 5. That's it. Keep in mind, for most questions, you also typically end up writing on the histogram as well. So like this bar might have been missing. I might have to draw it in. Question here. Estimate the number of motorists who were delayed between 8.5 and 13.5 minutes. So 8.5 is where this little fella starts, and 13.5 will include all of this and then some of this gang here. So it's not all of it. We know this range actually goes from 12.5 to 15.5. So we can see that because 13.5 is 1 minute into this class and has a width of 3, we want a third of our values. Again, this thing we're doing right now is what makes an estimate and not an exact value. So number of motorists, we have 21 from here, we've got 45 from here, and then because we're a third of the class within here, we then want a third of 9, which gives us 3. Add those together, and that would be your right answer. In this case, I think it comes to 69. Okay. Comparing data, last thing, I'm not going to talk for it anymore. When you compare data, you must comment on 2 things. You must include an average, either the median or mean, and then some measure of spread. You've basically got a choice. There's actually a 4th I've missed out. You can have range, interquartile range, that's the one, and standard deviation. Any of those 3 are valid measures of spreads. You must include one of each, and again you must do something about it, like Class A has a higher average, but Class B has a bigger interquartile range. Okay, that's what you must do to ensure you always get full marks. And that's it. That's all we have to say on Chapter 3. Hope that was useful.